Our new lesson is the cathode ray oscilloscope. The lesson has two parts, in two separate videos. The first video is the inside of the CRO. The second video is about how to deal with the CRO interface. In the first part inside the CRO, first we will study the basic idea that led to the manufacture of the CRO. This idea is the cathode ray tube. Then we will go ahead to study the parts of the CRO, the electron gun, the deflection system, and the fluorescent screen. Then we will take some examples for more details about its function. What we need from this thing is to produce electrons that move in vacuum, with no wires. The cathode ray tube contains a vacuum tube. Inside this vacuum tube is a highly negative cathode and a highly positive anode. They are separated by vacuum. They are connected to a high voltage DC supply, about 600 volts. If the cathode is heated, electrons of the metal atoms are excited and move a little away from their nuclei and immediately go back. So when the DC supply is switched on, the negative electrons are repelled from the negative cathode and attracted to the positive anode, flying in vacuum with no wires. This is how we can get a beam of electrons in vacuum. The cathode ray tube. You may be asked to draw a simple diagram for the apparatus. First, we will draw the vacuum tube. This is the highly negative cathode that will emit electrons. Opposite to the cathode, we draw the anode, which is highly positive. The cathode and the anode are connected to a high voltage DC supply. And finally, do not forget to draw the heater or the filament that will heat up the cathode. These are the apparatus, but what is the story? What do we want from these apparatus? All what we need is to get a beam of electrons between the cathode and the anode with no conducting materials. We can say, to make electrons travel in a beam out of a metal conductor. The first idea they thought about is to use a very high voltage DC supply, nearly 600 volts. Its negative pole is connected to the cathode, and its positive is connected to the anode. But it didn't work. So we can say, number 1, high DC voltage is not enough. After that, they thought about using vacuum to avoid electrons being stopped by air molecules. So they put the anode and the cathode in a perfectly closed vacuum tube. But even the use of high voltage and vacuum, the trial failed. The third idea they thought about is to add a heater to heat the cathode. This will cause what they call later thermionic emission. During thermionic emission, electrons are released a little from the surface of the heated metallic cathode. If the high voltage DC supply is now connected, in the presence of the vacuum and the heated cathode, electrons are completely released from the cathode, attracted and accelerated towards the anode. Now we got a beam of electrons moving in vacuum out of the conducting material. Some modifications are made to the cathode ray tube to invent the cathode ray oscilloscope, CRO. The cathode ray oscilloscope is built up of 3 main parts. The first part, which looks like the cathode ray tube but with a few changes, is named the electron gun. This part produces electrons by the property of thermionic emission. The second part is the deflection system, and it causes the deviation of the electrons from its normal straight line pathway according to the voltage applied to the plates. It consists of the Y plates, They are responsible for deflecting the beam of electrons vertically up and down. The other two plates are named the X plates, and they are responsible for deflecting the beam horizontally left and right across the screen. The voltage on the X plate is controlled by a button on the interface. This button is referred to as the time base. The third main part of the oscilloscope is the fluorescent screen. This screen is plated from inside with a layer of a substance that is sensitive to electrons. It gives a bright spot on the position where the beam of electrons falls on the screen. In this part, we will learn how to draw a label diagram of the CRO. First, you must draw this shape that will indicate the vacuum tube that encloses most of the parts. Starting from the left, the cathode is drawn as a basic cylindrical shape. The heater or the filament with its supply are drawn as a circuit behind the cathode. The hollow tubes are drawn to represent the anodes. Between the cathode and the anode there is a ring. This ring is known as the grid. Now the cathode and the two hollow tube anodes are connected to a high voltage DC supply about 600 volts. The negative is connected to the cathode and the positive to the anodes. Two parallel horizontal plates are drawn to represent the Y plates. Next to these plates are two parallel vertical plates to represent the X plates. And finally, this is the beam of electrons. This will make a flash on the screen. This is how you will draw it in the exam. Now label the parts. All the apparatus are placed in a vacuum tube. Starting from left, the labels are the heater or the filament, the cathode, the grid, the two hollow tube anodes, the high voltage DC supply, and all these parts form the electron gun, the Y plates and the X plates. And these will form the deflection system. The last part is the fluorescent screen. This is how you will draw and label the parts of the cathode ray oscilloscope.